Hello class, it's Mr. Calvin here again, and I'm here to present the next lesson here for chapter 9. And this time we will be looking at the surface area of prisms and pyramids. Now remember in yesterday's lesson we looked at the same shapes, prisms and pyramids, but we looked at the volume. And remember the way that for you to understand volume is that when you take a look at any shape, whether it's a prism or a pyramid, the volume was the amount of space that it took, that something takes up. So a good example of that is that if you have bottled water, for example, the water inside the bottle would be an example for volume. So, well, what is surface area? So what surface area is going to involve, as you're going to see in these examples, is we're now looking at the outside or the faces that make up the shape. And what surface area is taking all those faces and then adding them all up. However, in today's lesson, we're going to use the formulas that are in our formula sheet there. So if you have the formula sheet that's in your package, okay, just take it out and make a reference for it because we will be using it in today's lesson. And in particular, I'm referring to this sheet over here. So if you take a look at this sheet over here, again, we'll be looking at the last three shapes on the right side here, the square-based pyramid, the rectangular prism, as well as the triangle prism. And as I mentioned before, we're now going to look at the surface area, which are these formulas in the middle here, middle of the right-hand side. So that's what we're going to look at in today's lesson. All right, so let's get straight to it. So when we're looking at surface area of prisms and pyramids, again, we're looking at the faces of these shapes over here. So the first thing we're just going to talk about here are the units for surface area. So when it comes to surface area, the units are always going to be units squared or square units. So if you recap what we did with the volume, remember that everything was cubic and had the little tiny 3 on top. With square units, it's going to be whatever the unit is for the measurement with a little tiny 2 on top. So that's why it's called square units there. All right, so when it comes to that, as I said before, when it comes to the shapes we're going to be looking at today, we're looking at all the faces grouped together and adding up all the areas together in one shot. And actually, we're just going to use formulas for us to do that here. All right, so when we're dealing with that, again, we're going to look at each shape separately, okay? And then keep in mind that when you have the formula in front of you, please have it handy as we will be referring to it in the examples that we'll be looking at in today's lesson. So the first shape that we're going to deal with here is a rectangular prism, and it's given by the formula as you can see on the screen here. And you're probably looking at those two formulas and asking yourself, what is the difference between the two? Basically, what the bottom formula here represents is the result of taking this 2 and performing distributive property to the 2 to each pair of letters there. Okay, so I strongly recommend you use the bottom formula simply because once you have the measurements, all you would need to do is put the measurements in for each variable respectively and just plug it in your calculator. So for a rectangular prism, quite often when you're looking at the length, width, and height, okay, the length is the bottom measurement or any bottom measurement based on the rectangular prism, okay, and the width would be the other bottom measurement. Okay, and then when it's sitting up or standing up here, the height is always going to be the vertical distance. So for example, I have my a drive in here, which is a perfect example of a rectangular prism. So when it comes to the surface area of a rectangular prism, okay, what you would have here are the two faces, which are the front. So this would be the front and the back. So those would be the same there. Okay, so those are two faces. Then you have another two faces for the top and the bottom. Okay, and then there are another two faces for the two sides here. That's why for each pair of letters you can see here, okay, that's why there's a 2 that's in front of each pair of letters. So that's understanding the formula and understanding what surface area is. Okay, all right, so the next prism that we're going to look at, and again, we dealt with this in the last lesson as well, are triangular-based prisms. So remember, when it comes to triangular-based prisms have 2 triangular faces and 3 rectangular faces. All right, and like I mentioned before, what we have to do here again is to use a formula. Now, what we have here again with a triangular-based prism is that what we would have there would be the 2 slants or 2 slanted sides there. And for the purposes of this lesson here, we're only going to be taking a look at equilateral or isosceles triangles where 2 of the sides happen to have the side length there. Okay, so that would be the 2 S's. Okay, the next one here would be length, okay, which is part of one of the rectangular faces. And we have the base, which is the bottom, the entire bottom of the triangular face, okay, and the height. Okay, so when you're looking at any shape that has a triangle, okay, make sure you see what information you have and what information you don't have. So quite often at times we would need to solve for a missing length there. Okay, so that's why I want you to have your formula sheet ready as we're going through these examples. All right. So the next one over here again is a square-based pyramid, and in this course we're only going to look at square-based pyramids. So with a square-based pyramid, the surface area is given by the formula 2bs plus b squared. Okay, so the two bottoms, the two b's here will be the same length, and that's why it's a square-based pyramid. So the square base always represents the bottom. Now, when we're looking at the faces of the triangle here, what we would have here would be four faces that are equal. So when we're looking at the S here, this is now referring to what's called the slant height, which is the height of one of the faces of the triangle there, okay? So please don't confuse this with the height that's in the middle, okay? So if you take a look at your formula sheet, you notice there's a height, okay, which happens to be going from the top of the pyramid to the center of the base, okay? Don't confuse that with this. The S represents the slant height, which is on the face of the triangular part of the pyramid. All right. Okay, so let's say some numbers over here because it's probably the easiest way to understand it. And the first thing we're going to do here again is just to do the surface area of a rectangular prism simply by using the formula. So again, the first thing you should do here is to label the sides according to those letters. So what we would have here would be a length of 2, okay, a width of 8, and a height of 4. Okay, and we're going to put these numbers in. We're going to substitute each of those letters with these numbers by putting it into brackets. Okay, and with a scientific calculator, if you actually put that all in one step and carefully do it, okay, you should get 112 square yards. Okay, so notice that we started off with yards as our measurement for each of the lengths, but since we're dealing with surface area, okay, what we have here is yards squared or square yards. All right. Okay, so nice and easy one to start off with. Now let's take it up a notch and take a look at triangular prisms. All right, so now we're going to look at the surface area of a triangular prism over here. And what we want to do here again is that remember with triangular based prisms, what we have to understand is that we have to make sure that we have all the measurements. So if you take a look at your formula sheet there, okay, just double check that you have all the measurements we need in order for us to solve this. All right, now, if you take a look at your formula sheet, okay, you notice there's a bunch of letters there. We have an S, an L, as well as a B and an H, okay? Trying to figure out if we're missing something or not. Now, if you guess that we are missing something, okay, you are absolutely right. Okay, we are actually missing the height that we do need in order to calculate the surface area of a triangular prism. So as you can see in the screen there, okay, the height that we need to solve for is indicated by the red line there. So we're going to take that up and just going to make it a little bit bigger. And the way we're going to solve for that red line there is using Pythagorean theorem, and that will be the height of the face of the triangle there. Okay, so I've just drew that on the side there. Okay, if you want to put a little tiny box in the bottom left-hand corner, okay, you can do that as well. Okay, so always start off by writing down the formula for Pythagorean theorem. And when you do that, notice I've labeled the side here as 11 centimeters. And the reason for that is because if you take a look at that red line, which I've outlined in the diagram on the right over here, when it starts from the top and then it goes to the bottom, it cuts the entire bottom in half there. That's why even though the entire bottom here is 22, when you cut it in half, when we're solving for the red line here, okay, you have to cut it in half, which makes it 11. Okay, so that's going to be 11 here. Okay, the hypotenuse, as you can see, has is the same length as the other two sides here. So this is going to be an equilateral triangle. So what we have here will be a hypotenuse here of 22. And what we want to do here is to use the Pythagorean theorem, okay, to solve for the side in red there. Now remember, you always label the hypotenuse first. The 22 would be the C, and we'll make the 11 as A. So that means we're going to be solving for the B over here. All right. So next step, we're just going to substitute those numbers. Okay, and in the next step, we're just going to simplify that. So 22 squared gives me 44, and 11 squared gives me 121. Now we're going to isolate the b squared on the right side over here by taking the 121, okay, and moving it to the other side and subtract it from the 44 that's already there. Okay, and last but not least, we have to take the square root of both sides. Okay, in your calculator, just take the square root of 363. Okay, and that'll give us a measurement there and the height of the triangle to be 19.1. Okay, so once you have that, make sure you label the diagram again so you can see exactly what information you have. Because in the next slide here, we're now going to calculate the surface area. using the measurements that you see on the screen there. Okay, so for the surface area, you notice we have an S, L, a B, and H to label. So starting off with the S here. Okay, so the S, remember, was the slanted length of the triangle here, so that will be the 22. Okay, the make up the slants there. Okay, our length here is 25. Okay, and for our base here, the base is now the entire bottom, which would be 22. Okay, and then our height here is the 19.1. All right. Okay, carefully put that into the formula like so. Okay, now again with scientific calculators, as long as you input that in exactly the way you see it, okay, you should get a surface area here of 2070.2 square centimeters. All right. Now, double check that if you did this in your calculator in one step and then you didn't get that answer, okay, you might have inputted something incorrectly there. So just double check that you have it, you've put in every piece of information there. All right, so that's dealing with the surface area of a triangular prism. So the next shape we're going to have, again, is going to be dealing with something that has triangles. So again, you might want to have your formula sheet ready here. And this time we're now dealing with a square-based pyramid. Now remember with a square-based pyramid, okay, we have a square bottom, so we have our two base lengths. So if you take a look at the shape again and your formula sheet, okay, I want you to see if there's anything missing. All right, now what's confusing about this one is that 36. Okay, that 36 in terms of where it is in this diagram is actually the slant length of the triangular face that you see in front. So we are missing something, and what we are missing here is actually the slant height. Now remember, the slant height is the height from the top of the pyramid on one of the triangular faces, okay, to the middle of the bottom. Okay, and I've drawn that with that bluish type of line there. Now, what that is, again, from the outside, is that's actually going to be a right angle triangle, and guess how we're going to solve that? Yep, you've guessed it, Pythagorean theorem. All right, so what we're going to do here is going to use Pythagorean theorem again. And what we're going to see here is that this bluish type of line starts from the top, and it's going to cut the base here exactly in half. So the bottom part here is going to be 6, okay, and the slanted part here is going to be 36. So notice that the diagram that I drew in on the face of the triangle, when you just push it to the side, you can see exactly where the numbers belong here. So in this case here, we're going to use the Pythagorean theorem. Again, the right angle for this triangle is located in the bottom right-hand corner there. So your C here would be the 36, because that would be the hypotenuse, okay? And we'll label the 6 here as A, okay? Now, when you put the numbers in, okay, we'll be solving for the B. So in the next step here, all I've done here is I've taken the 36, replaced the C, and taken the 6, replaced the A. So we're going to simplify each one here. So 36 squared gives me 1296, and 6 squared gives me 36, all right? Now, again, just like we did with the previous example, we're going to leave the b squared where it is. So we're going to take the 36, okay, move to the other side, and then subtract it from the 1296 that's already there. Okay, and last but not least, take the square root of both sides. So that blue line, which now represents the slanted height, is going to be 35.5 feet. Okay, so as you're moving along here, make sure that you're anything that you have to solve for, that you put into the original diagram, so you can see what information you have and what you don't have. In this case, we should have everything that we have. All right, so the next thing we want to do, let's calculate the surface area of this thing. Okay, so remember our bases here are the two 12s. They're both the same. Okay, and what we have here for the S now, okay, is that the measure of that blue line that you see on the screen there. So that's going to be 35.5. Okay, and when you put the numbers into the calculator, okay, don't forget that that second set of 12s on the right side there. It needs to be squared. Okay, we should get a measurement there of 996 square feet. All right. Okay, so that wraps up the surface area of prisms of pyramids. Okay, so I'll see you in the next lesson.